So next we have a two-part presentation on the importance of data from an end user's perspective. Teresa Najita, Air Pollution Specialist for CARB's Air Quality Planning and Surveillance Division, will be giving the point of view of a technical data user in a planning environment. And after her, we have Yushuo Chang, Manager of Planning and Monitoring for the Placer County Air Pollution Control District, and he'll be giving the point of view of an end user who uses the data for community purposes. So if you have any questions for Teresa, please hold those until after Yushuo has spoken. Great, thanks.
Can everybody hear me? Hopefully. So unlike your previous speakers, I don't do very good at memorizing, and I'm not very good at speaking off the cuff, so I have my crutch in hand, and that way I'll stay on topic. So we use the data. I'm from the planning branch of the California Air Resources Board, and we use the data that you collect in a myriad of ways, but they all get to the core of our mission, which is protecting the public from the harmful effects of air pollution. So to do that, we need to figure out what is in the air, try to determine how it got there, help find solutions to reduce it, and then figure out if these solutions are actually working. So first, we need to know the basics of what is in the air and where our trouble spots are. So for this, we use data from an extensive monitoring network, and that's all you guys. So some data is available almost immediately. Others, like data from filter or speciation monitors, can take months to see the light of day. Once all this data is in, statistics are calculated for each of the criteria pollutants at each monitoring site. So the statistics are used to help us determine where the data from the monitor stands in relation to the state and federal standards. These are the state and federal ambient air quality standards. So for those who might not know, both state and the federal government have determined that air pollution above a certain level, called the standard, is unhealthy. For each criteria pollutant, there are different standards and different averaging times. For example, ozone has one federal standard, and it's averaged over an 8-hour period. PM 2.5 has two federal standards. One is averaged over 24 hours, and the other is averaged over the entire year. So there are 10 state criteria pollutants with 17 standards, 6 federal pollutants with 13 primary standards. So if the data shows that an area is over any of these standards, the area could be declared in non-attainment. And then we have to come up with ways to bring the pollution levels down. So this map shows you non-attainment areas for 2 of the federal standards, ozone and the PM 2.5 annual standard. So I want you to bring your attention to the small area up in the mountain counties and this area down in Imperial County, because I'm going to be talking about them. So we use the data to identify where we have the problems. We also use the data to determine what these problems are. This is almost like a forensic investigation. So this area is the Portola PM 2.5 non-attainment area in Plumas County. So the area was designated non-attainment when the PM 2.5 annual standard was revised in 2012. In order to come up with a plan to reduce the pollution here, we needed to know what was going on. So as you can see in the top graph, monthly averages for all PM 2.5 concentrations, and in the bottom graph, hourly averages during the most polluted days. And as you can see, the problems were both seasonal, highest in the winter, and diurnal, which is highest overnight. The monitoring site also collects speciation data. So the data from the speciation monitor was used in a statistical modeling program, and the resulting output gives us a better understanding of what's going on. As you can see, the main culprit in this area is wood burning. With one primary source of pollution, addressing the problem becomes a little bit easier. Not everything is this straightforward, however. This is the Imperial County PM 2.5 non-attainment area. Luckily, we also have a speciation monitor down here in Calexico, right on the border. Again, we threw this data into our statistical modeling program, and this is what came out. As you can see, the area is almost equally affected by a variety of sources. And this makes tackling the problems there quite a bit more complicated. So now, using both meteorological and air quality data, we can get an idea of where sources are in relationship to the monitor, which does help. So looking at just the mobile sources, you see that the mobile impacts come from all around the monitor, which you would expect. These are mobile sources. The largest sources, however, seem to be from the south and the southwest, from the direction of Mexicali and the Mexican border crossing area. So what do we do once we've identified our culprits? This is yet another use for the data, helping find and refine solutions. So the main avenue is the State Implementation Plan, or SIP. Now this is an overarching plan of the state and the districts to reduce emissions and improve the air that we breathe. It's not a single document. You can't just email me and tell me, ask me, send me the document, I'm having trouble sleeping. It's a vast collection of legal requirements, rules and regulations, programs, data analysis, modeling results, historical perspectives, and strategies. This pyramid shows the basic elements that go into crafting the state SIP. I want you to note that air quality monitoring is the base. Everything else results from that. Everything builds on that. Now you can see how the data helps with one of the many pieces of the SIP. The fun one, rules and regulations. The state and local districts implement programs designed to decrease emissions from various sources. So how does the data that you collect come into play here? So you can use the data to try to figure out if a program is working, for example. We were trying to determine how effective a Don't Like Tonight program was. So continuous meteorological and air quality data were used to decide if a district should call for restricted wood burning or just ban it altogether. So the closer view shows us, what the district decisions were and what we decided they should have been, which is easier to do after the fact. The red boxes indicate where we thought the district should have been more stricter in their decisions. The green indicates that the district was a little stricter than was potentially needed. So unless the district has consistent, accurate, and timely data to make these decisions, they may be making the wrong decisions. So here we see what was going on concentration rise during this time. So I'm going to look at this little slice here. And as you can see, the concentrations start to build and continue to climb, even with the district restricting burning. But here we're finally getting a decrease in concentrations. So your initial reaction is, the program is working. But stagnant conditions were in effect. They were in place, which means nothing was going on. Nothing was moving, and concentrations were building up. So these stagnant conditions were lifted when a weather system came through and bringing wind and rain, something that tends to clean out the atmosphere. So the reaction is, it was a system that did it. But this one data point, indicates that the concentrations were starting to lower before the system came in. Without this one data point, we might make the wrong conclusion of what was going on. Would we have finally gotten here to the level of the standard without the help of the system that came through? Would concentrations have gotten higher without the program in place? We need as much quality data as we can to understand what was going on and to help us refine our solutions. We use the data to evaluate the overall progress that we've made. So we can evaluate the progress from a regulatory perspective. How close are we to attaining the standards? Here, for example, you can see that the South Coast Air Basin has been making steady progress to attaining both the PM 2.5 annual and the PM 2.5 24-hour standards. You can look at other ways to evaluate progress. One commonly used metric is days over the standard. And you can see here on the top that the number of days that people have been exposed to unhealthy air has been decreasing considerably. In looking a little deeper into the data, on the bottom, you can see that the average concentration of the days that do exceed has also decreased. So the data that you are responsible for is used not just for what I highlighted, SIP development and program evaluation, but all these other areas, listing just a few. We use the data to answer the fundamental questions of what, where, why, and how. What is in our air? Where are our problem areas? Why do these areas face the challenges they do? And how can we improve their air quality? To answer these questions and more, every single data point matters. Data must be collected in a consistent manner. It must be accessible and available as soon as possible. And it must be something that everyone can trust. So we can make all the plans we want, but without consistently available quality data to back them up, they won't make any sense. Thank you.